Now we're going to look at solving some radical equations. So what you want to do here is you want to undo what's been done. So you want to isolate a radical, and then you need to square both sides to get rid of that square root. If this had been a cube root, you'd want to cube both sides. So you want to undo what's been done. So the opposite of square rooting something is squaring it. And when you square a square root, it cancels it out. So I get 3x plus 1 is equal to 4 squared, which is 16. Subtract 1 from both sides. You get 3x is equal to 15. Divide by 3 on both sides. You get x is equal to 5. And you do want to make sure that this will work. So the square root of 3 times 5 plus 1 would be the square root of 16, which is 4. So it checks out. X equals 5 works. All right, next problem is going to have a square root and a variable that's not under a square root. So again, you want to isolate this square root. So I'm going to leave this square root of x plus 7. And what I'm going to do is I'm going to move this over here. So it's x minus 5 when I move the 5 to the right. So now I'm going to square both sides. Again, when you square a square root, it cancels it out. And here on this side, if I square x minus 5, I actually have to write it down twice and distribute these, or some of you say FOIL. So x plus 7 equals, this would be x squared minus 5x plus 25. So I get, I'm going to get everything set equal to 0, so I'm going to subtract x and subtract 7, which gives me 0 equals, subtract x and subtract 7, x squared. This would be minus 5x, and minus x would be minus 11x. And then 25 minus 7 would make plus 18. So I think this can be factored. X and x, I've got a minus 9 and a minus 2. Those two numbers multiply to give me 18 and add up to negative 11. So x can be either 9 or 2. And if x is 9, let's check and make sure these will work. So 5 plus the square root of 9 plus 7 equal 9. So that's 5 plus the square root of 16. 5 plus the square root of 16 equals 9. 5 plus 4 does equal 9. So 9 works. What about 2? 5 plus the square root of 2 plus 7 equals 2. Well, it's not going to equal 2 because 5 plus something else that's a positive number won't equal 2. So my only answer that's going to work is 9. And then finally, I want to work one similar to number 67 on your homework where you have two radicals. And what you want to do here is you want to isolate one on one side of the equal. So I'm going to leave the x minus 3 here and move this one over here so it become 4 minus the square root of x plus 5. And I'm going to square both sides. Again, when I square this expression on the right, it's got two terms, so I've actually got to write it down twice and do FOIL or distribute. So this side becomes x minus 3, and this side I'm going to write down twice. Okay, so x minus 3 equals, this would be 16 minus 4 square root of x plus 5. 4 times square root of x plus 5, and then the inners would be minus 4 square root of x plus 5. And for the last one, minus square root of x plus 5 times minus square root of x plus 5 is going to be plus x plus 5. So I need to do some gathering over here and see if I can put some of these things together. I've got 16 plus 5, that's 21. Then I've got plus x. If I put these two together, that's minus 8 square root of x plus 5. Subtract 21. And that makes negative 24, subtract x, and that's just gone. And so I'd have negative 24 equals negative 8 square root of x plus 5. Divide by negative 8. So I get 3 equals the square root of x plus 5. Square both sides. I get 9 equals x plus 5. Subtract 5, I get x is equal to 4. Let's make sure that'll work. The square root of 4 minus 3 plus the square root of 4 plus 5 equals 4. So that's 1 plus, this would be the square root of 9, which is 3. 1 plus 3 equals 4, and that checks out. So that's 3 examples of radical equations, and in a minute we're going to do some formulas.